Hi, this is James Pura, and I'm here to demonstrate the hex meshing workflow inside of the new release of MSC APEX Harris Hawk. So I have two models that I'm going to show you today. The first one is this solid component, which will do some solid splitting and hex meshing. And then a little bit more realistic workflow, we'll do it on this part here. We'll do the same thing, solid splitting and hex meshing. So for the first model here, the key to hex meshing, which has been uh, really the longest meshing workflow of the four, we're talking 1D beams, 2D shell, 3D TETs, and then 3D hex. The longest time to pre-process a hex mesh has traditionally been hex meshing, and that's mainly because you have to, in order to get a coincident mesh along a boundary, you have to do some significant solid splitting and just a lot of work in order to get to a completed mesh. Apex Hawk addresses a lot of those concerns, which I'll walk through here today. The first one is a part here which you can see lends itself well to a hex meshing workflow. There's not a whole lot of fillets or chamfers or anything like that on this part, so we're going to use it to demonstrate the hex mesh. So the first thing that I wanted to show you is that right up here you can click on the icon that says display using 2.5D color, and notice that if I go over here to hex meshing and I click on it, notice that I can't click it. It will actually give me a red circle with a line through it and says selected body cannot be hex meshed. So it gives me instant feedback that I can't mesh that. So what I need to do is I need to go into the split tool, which is right up here in the geometry edit tools family. And as I split, I'm going to split using surface. Now I can also split using a cutting plane as well, which you can use to define on your geometry. But I'm going to use a split surface because I'm gonna tunnel out this or core out this cylinder in here, and I'm going to use the inside surface there. Now notice that as soon as I select that and split it, it's immediately hex meshable. Now if I go up here and I say select by cell, I can hover over, right click, and say show only. Now notice that this is part of the greater solid, but it's removed the rest of the part from the visual plane. So here I can go in and I can actually hex mesh this part all by itself if I wanted to. Now that's a little too coarse, so I'm going to go a little bit smaller and see what happens. Now notice I don't have to delete any of this mesh as I'm going. I can just immediately choose a different size mesh and I can go with it, and I don't have to go in and delete it first. So also notice that it just immediately puts the mesh and the solid part into the same part file as the solid geometry, so you don't have to do any housekeeping, and it kind of saves you time and effort that way. Now this mesh doesn't look as nice as the other one, but what happens if I want a nice clean through thickness of three evenly spaced elements along the face and have it extruded throughout in the entire part? Well, I could do it the old-fashioned way, which is if I delete, I'm going to go in and delete this mesh, and I'm going to do a 2D surface mesh on this surface first and then extrude it through the solid. So I'm going to click on faces here, and I'm going to select this top face, and I'm just going to go in here and choose a mesh size that gives me three evenly spaced elements through the thickness there. Now if I go into hex meshing now, it doesn't matter what size I choose, Apex will automatically recognize the fact that there is a mesh on this top face, and it'll go ahead and match it up. Now if you don't believe me, watch me as I uncheck this surface mesh here, and notice that the 3D hex mesh is the only one that's visualized right now, and sure enough it has automatically extruded that 2D surface mesh. So I can go in and I can actually just delete it right here. So now that's the old workflow. Now if I wanted to delete that and bring it back, I can actually just mesh directly with that size, and it'll go ahead and do it without having a 2D surface mesh first. So I'm just going to bring back the entire solid and do a little bit more of this work as I go. Now you can do all of the splitting beforehand, or you can do, split a little bit and mesh a little bit as you go through your solid. It's completely up to you. Apex does not have one single recommended workflow. A lot of these tools kind of are designed to work, whether you mesh first and then split later, or mesh later and split first, whatever you want to do. So hex meshing is a little bit restrictive in the sense that you have to get a meshable solid first, or at least a meshable cell first before you mesh. So let's go back to the split tool, and I'm going to keep the split using surface icon, and I'm going to split using this surface there. Notice that that immediately turns green, and I'm going to select the rest of this cell. Now that cylinder is green, and then I'm just going to click on this surface here. Okay, now that's green. Now I only have one remaining cell, and it's because it has this little indentation here. So if I select this cell and I select the surfaces on the inside, and then middle mouse button to execute, notice that now I have a complete meshable solid. Now I can do one of two things now that I'm ready to mesh. The first thing is that just like the rest of Apex, there's kind of like a manual method of doing things, and there's this a quick automatic method of doing things as well. I'll demonstrate both here for a second. So here you can do the more manual method where you select one cell at a time, and you can mesh it using whatever size that you deem necessary for your part. Now, the quick and dirty way of doing it is a lot faster, where if I delete this mesh and I just drag a box around the entire solid, sure enough, it'll mesh all of it without me actually having to define which ones to mesh first. Now, that is by design, okay? Also notice that, that it kept our 3 elements through the thickness because we had the same mesh size here. But what happens if after it's meshed we want to change the mesh? Let's say we want to do a mesh seed. Well, you can do that as well. So let's go into mesh seeding, and let's say I wanted 10 elements around the inside edge of that circle. Notice that it'll immediately change. Okay, now if I wanted to change that mesh seed dynamically or on the fly, I can do that too by just increasing the values and going along as I want. Okay, now I can also play around with the geometry and change the geometry, and the mesh will go along for the ride. So why don't I go over here to push pull, and I'm going to change the inner diameter of this hole here. Currently it's at 2 millimeters. Let's just bring it out to, say, 3 millimeters. Notice that the diameter automatically changed and the mesh automatically changed as well, okay, which is quite nice. Now, I can also do some additional push pulling, show the dynamic change of the mesh. So I'm just going to manually pull this out a little bit. Notice how the mesh will automatically update. I'm also going to add a chamfer to this edge here. Okay, notice that once I click on the edge, it also has add, adjust, fillet, or chamfer. I'll do one of each. Let's add a fillet on this upper edge here. And then on this lower edge down here, let's add a chamfer. Now again, you can manually pull this back, which kind of gives you an arbitrary 2.2 millimeters, or you can undo that. Apex has up to 50 undos in a row if you want, and you could just change that to say 2.5, and it'll manually create it for your exacting specifications. Okay, now that is the end of this first part, so let's go ahead and switch over to a more realistic hex mesh, which is this aerospace style bulkhead part. Now this is designed to be like a machined aluminum part that is subtractive manufacturing, which normally you would machine this out of, say, a block of aluminum or something like that. So as we investigate the geometry, there's a couple of things that I want to draw your attention to. The first one is the fact that look at how they have some chamfers up here and some fillets as well, which is going to play a role in how we define the hex meshing and solid splitting. Also notice that I'm going to pretend that I forgot to defeature a chamfer on this part, and I'm going to demonstrate how Apex kind of deals with that. Okay, so the first thing is that let's go ahead and defeature some of this stuff. Okay, now if we want to defeature, again, there's a manual method and an automatic method, which we can use to defeature different parts. So the manual method is by selected face, which is just a one-click kind of option, especially when you have the lightning bolt on. So I can click on them one at a time, and it'll disappear. Now I can also go over here and I can get rid of fillets as well if I wanted to. Okay, fillets, chamfers, holes, whatever I want to do, I can do it. Okay, now I'm going to undo that just because I'm going to keep that feature inside of my geometry. But I wanted to show you that the same feature works on chamfers and fillets and holes all at once without having to choose a different option or anything like that. Now, I can also go over here to this chamfer that I forgot, and notice what happens when I click on it. It gives me an error. It says deleted faces failed. Now, this is because our human eyes are deceiving us. To our human eyes, as we inspect this, this looks like a normal chamfer that has nothing wrong with it, but mathematically there is something wrong with it. Either there's a missing vertex or a surface on top of another surface, or something that is maybe like a little wave or two edges that are occupying the same space. Something mathematically, when Apex turned this into a group of ones and zeros, something's not adding up correctly, which means that there needs to be some geometric cleanup happening before we actually defeature that. So thankfully, Apex has a geometry cleanup option, which I'm going to go ahead and use the default value of the non-general body simplify and leave all the default tolerances as well. Now notice down here it says status is cleaned body, which means that it was successful. And so let's just go back to where we were before and see if it worked. So we go back to defeature, we click on this fillet, and sure enough now it's gone. Okay, so that's just another tool for you to keep in your arsenal. So now that we are ready to hex mesh this part, let's go ahead and turn on display using 2.5D color. And yes, I have noticed that there are still a couple of more chamfers, but I'm going to do the more traditional standard real world workflow where maybe we forgot something and we're going to address it after the fact. Okay, so let's go into the split tool. And notice here that you have instructions right at the mouse cursor, okay? So select the entities you want to split, then select the middle mouse button. So I select the entity, and then I want to select this inner surface here. Now, again, there is a manual method and an automatic method of selecting the surfaces. So if I wanted to select the inside surfaces here to split, I could do this and select these surfaces to split with. And then I middle mouse button click, and notice that now I have a meshable solid, which is green. Now I'm going to do this again with the more automatic method, which is right here. So I'm going to select cells, split with cells, and again it says split using surface, and I'm going to select this cell. And then I'm going to do Alt double click. Now if I hold Alt and I double click any of the surfaces in this surface, watch what happens. It automatically selects a complete loop of surfaces, and then as I middle mouse button click to execute, it goes. Now I can go a little bit faster now that I've got this method down. Alt double click. And then here is nice because notice that I'm going to get 2 in 1 because this surface here right here is actually shared by both cells. So if I Alt double click that, notice it selects all the surfaces, and it actually splits both of those cells at once, which is quite nice. Now I'm just going to do this a couple more times in order to get a meshable solid. And one more time. Now, as we inspect our solid and we rotate it around, we basically only have one more part that we need to hex mesh, which is this outer frame here. So I'm going to right click and I'm going to say show only. Now notice as we inspect this, there's a couple of things that we know right off the bat that's going to prevent us from being able to hex mesh this part. First of all is this step right here. So if we split using this top surface here, notice it highlights it as I hover over it, and then I middle mouse button to execute. Notice that the bottom half is now completely meshable, but there is something wrong with this top surface here, and oh, sure enough, I forgot to defeature a chamfer. So let's go over to, oh, and it also looks like I've got an additional fillet that I need to get rid of as well. That's probably what's causing it. So let's go ahead and get rid of those. Now watch what happens as I go back to defeature. Notice as I hover over it, it says any faces on a cellular solid is not supported. Well, are we stuck? Do we have no other options? No, definitely not. So what we do is we go to the push-pull tool, and we click on that fillet. And notice as we pull it back in, we can actually get rid of it, or we can even do an up to, where we match this face to this face, and sure enough, now it's nice and clean. Now, we can also do the same thing, which is right over here on this chamfer, and we're just going to pull it out to where that chamfer no longer exists. And sure enough, look, now it's nice and clean and meshable. I'm going to do it one more time for this chamfer here, even though the part's green, just because I want to get rid of it and have a nice clean mesh at the end of it. So now, as I right-click and I say Show All, notice how all of the cells are green and I am ready to mesh. Now, at this point, yes, I can do some 2D surface meshing if I wanted to dial in my mesh exactly the way I want it to, but instead I'm just going to go straight to 2.5D meshing, and I'm going to drag a box around the entire part. Notice now how the mesh looks pretty good, and I am ready to go. Now, if I want to do a smaller mesh, I absolutely could. Let's say the pretty standard workflow is saying that I want 2 to 3 elements along the machined edge, the short edge, if you will. I can just keep guessing and checking, or I can do a mesh seed if I want to control it further. Okay, so just do it one more time. And there you go. You have 2 elements through the through thickness. Now, at any point in time, if you wanted to reduce the element size, because this mesh is pretty fine, it's going to take a little bit longer to run than it would the first time we meshed it, but that's okay. Maybe that's what you want as the user. But if you wanted to go back and refine the mesh however you wanted to, remember Apex is completely generative. So if you wanted to change the geometry, or if you wanted to change the 2D surface mesh and have it line up, you absolutely can do that. Okay. This concludes the demonstration of Apex hex meshing in Harris Hawk. Thank you.